All right, welcome back, everybody. It's been a crazy December, I'm sure for you guys as well. So hopefully, if the internet goes bad or if I clip out, tell me. I can turn off my video, um, and that should maybe help a little bit. Uh, the real issue I think here with the cable system here in France is not so much the download; it's the uplink all the way back to the United States. So that's where I think the trouble is. So we'll take a wing for it. All right, probably give it like another minute, give people a chance. So anything fun during December? And we do anything cool, exciting, neat? I don't recommend getting COVID overseas.
Well, I had the first part. I got the COVID, but rather at home. So
Yeah, that's
I'm
fair.
stuck here for the next 5 days for another 5 days quarantining. So
Yeah, I flew over to France while I was in flight. They changed the rules and they removed my pass sanitaire. So I landed, found out that I needed an extra booster. I can't get a booster and I can't go into restaurants. Then 2 days later, I came down with COVID. So,
oh no, that's
so it's been
unlucky.
3 weeks of I might as well be in Ohio.
Yeah, that's fair. Yeah, that's rough.
So,
One of
all
my
right.
uncles had something similar happen. They changed the rules and he was like passing through Ireland. But with the
Yeah.
time change, it was a 2 day notice for a 3 day test. So he paid Cook County their $250 at the airport. And then, like, once he got on the plane, they changed the rules because they realized the time change meant anybody coming from US couldn't get a test in time.
Well, they added a second booster here while I was
Hmm.
flying. So I land, but I can't get a booster because I'm not a French citizen. And I don't qualify because I don't have the extra booster. So I'm like in this total screwed state. Um, yeah, just a disaster. For the record, going to French church, listening to German songs sung in French feels very weird. Like every song's like going, it should be German or English, and then all of a sudden it's French. So it's like really weird. Um, that was kind of like the highlight because you can sneak into church without getting yelled at. All right, let's start this. All right, so this is SE456, and the class title is called Real Time, no, Architecture Real Time Systems. And somebody told me this, and I totally freaked out. It's the initials as arts. So technically, I'm teaching an art class, which is like the worst fit you can get on earth. So I thought that was kind of cute. So I can't see everybody. So just when you have a question, just stop and ask questions. Very informal, very easygoing. We're going to debate a lot here. We're going to argue and kind of tease out certain behaviors and properties. And that only works if you guys participate. So please do so. All right. So today is kind of an easy day. This is the day I go through the syllabus, kind of do the basics. We start on our first assignment, and just scare the crap out of you, and that's the job, right? So in retrospect, this class I think is technically easy. If you know how to create a class, you know how to create methods, you know inheritance, you have all the mechanics of this class. The complexity is that we're going to make a lot of classes, and the classes glue together in such a way to create complexity. So, has anybody played the game Go? Go. It's a game from Asia. It's a super hard game, and
I've tried it a couple times, but I can't say I'm any good at it.
Yeah, it's you know it's get rid of this. Here it is. It's just um, white and black stones. You put them on the crisscross intersections, and there's like 4 rules. That's it, and you can surround and capture and start to get more stones and hold more area. So what's awesome about this game is if you haven't get a chance, you can play a version of this called I Go In. Um, it's kind of a fun game, but it's very, very challenging. You think you're doing well, all of a sudden, 2 seconds later, you just lost the whole game. Um, but what's interesting about this is there's only like 3 or 4 rules to the whole game. By the way, the word Atari comes from this game. So it's a little like side trivia. But um, but what's nice about this is small number of rules, infinite complexity, right? And this is one of those games where it's hard to get anybody who's a ranked master at this. Computer programs have a hard time trying to beat masters, where they can beat masters left and right in chess. They can't beat them in Go. This shows you that the expansion of possibilities and side effects are just endless with this game. And the reason I bring this up is that design patterns. We're going to be using very, very simple constructs, methods, construction, inheritance, and from that we're going to create complexity. And that complexity is kind of profound with just these simple little building blocks and building rules. And that's where the game kind of, the whole application gets more interesting there, is that there's certain techniques and certain processes to solve certain scenarios better, right? So let me go through the syllabus real quickly. So I'm trying to figure out how to hide this. Put it there. All right. So here we are. We're gonna meet basically 6 to 9 p.m. Every Wednesday, and the everything's recorded. So it is real time here, and if you can't attend, just watch the recording. All the notes I will post after class, and then it takes a while for me to convert, but I'll convert all the videos. Also turn on the transcribe, so it will do closed caption if you desire, and put that up on YouTube. And this way, the YouTube is nice is that you can pause, scrub, play faster, play slower, and also can have it run at different kind of fidelity marks, different resolution, so you can deal with lower bandwidth versus high bandwidth. All right, so the class here is just we're going to learn about design patterns. And this is different than SE450 in such that 450, I think, well, maybe I should turn it around to the class. What is, has anybody taken 450?
450 is the Java version.
Yes. Has anybody taken that course?
Yeah.
Can summarize it maybe?
You make paint.
It's so it's 450. I know a lot of students take both of these classes, which is totally cool. But they all kind of universally say that they seem to. I lost all the students.
We can still hear you.
Yeah, you can hear you. But I can't see you guys at all. All of a sudden.
Hey, Professor, it's a little.
Yeah, go ahead.
You're coming in kind of soft compared to everybody else.
I'm coming in soft. I'm not sure what I can do to change that. Here, let me go to the microphone setting.
At least on my end. I know some other people said they weren't having the issue, but for me, I've got my volume up all the way. And everyone else who speaks, I hear very loudly, but you, I can't really hear that well.
So can you hear me now? No, yeah, it does look a little low.
It's about the same on my end.
What about now?
Still pretty quiet.
Yeah, it's still quiet. All right, what about now? Any better? Worse?
I
Yeah, I'm trying to think. So I
think
have,
it's about the same, but I think you were cranking up your output level as opposed.
yeah, well, I'm trying to crank anything to move my gain. I can't move my volume right
Okay.
now.
I think what you're doing is changing what you hear rather than what we hear currently.
Yes. Do you know where the setting is?
I'm guessing it's the microphone underneath speaker. Whenever you spoke, the input level under the
Oh yeah,
microphone setting.
I can see that. It's just how do you adjust it so you can tweak it where it's stronger?
I do not know how to do that in Zoom.
Yeah, same thing. I can see the it's not peaking as high as I want it to peak.
Maybe volume underneath there would help.
Yeah, I can't move it. That's why I was trying the other thing. Yeah. So everything you said so far, yes, I tried.
Oh,
Um,
well then.
You
Maybe
feel
turn off automatically adjust microphone volume.
yes, yeah, there you go. That might be it. Yes. All right, let's try this.
There you go.
Oh,
Too loud?
nope. Yeah.
That is better though.
Better?
that's better.
Better. Okay, I just killed Robin. Robin can't hear now.
Well, it was like it swapped to only doing like one side really, really loud briefly there, and it was not nice.
No, no, sorry about that. Yeah.
Okay.
I think this is better. At least I'm seeing bigger bars. All right. Is this improving a little bit?
Yeah,
Okay.
I think that's a little bit louder.
Okay. Thank you. Sorry about that.
Yeah, thank you for making the adjustment.
Oh no, no worries. I can't hear it. So, and that kind of correlates with what people were saying yesterday. Um, all right. So 450. Some people took 450. Anyone want to summarize that class? Do you do design patterns? I would assume.
We did
well-
do design patterns, but I think it was like a couple, and we kind of targeted them, and it was more identifying and like looking at code and identifying what pattern was in use than actually designing a system with them.
Okay. Anybody else can add to that?
Made a paint application that didn't have to utilize real-time code.
How much? How many patterns?
I think 12,
You use 12 at the same time?
or I think
I
have to
would.
look at-
I would.
look at seven.
I'm gonna call BS on that.
it might have been 7.
I'm still gonna call double BS on that
I
It's
remember
okay.
only like
because
two,
the reason why I say
four,
that is
6 maybe.
historically, this is a loaded question. I ask the question and I get the same answer, and people have been taking the course for years. They've used 3 to 4 patterns at a time. We're gonna use 15 at the same time. So it will take you the full 10 weeks to use 15 patterns. So if your project started week 1 and it took you 10 weeks to do it, then maybe you use more than 7. But there's no way you use that many that quickly. So, all right. So what we're going to do is we're going to have about 100 to 150 classes. And we're using. So you're going to create these classes from scratch. So think about it. If you're going to create 150 classes, you're probably going to write each class on average, write it, throw it away, modify it, write it, throw it away, modify it at least 3 times. So you can start seeing there's 150 times 3. You're going to be doing a lot of coding. And you'll get so far, and then you'll realize that your foundation that you built was wrong. You have to turn around and tear that back up and rework it. So, we're going to use about 12 to 15 patterns simultaneously, and we're going to be replicating these patterns all over the place and generating a lot of code. The good news is the code is really small, self-describing, because there are going to be few lines of code. If we do the classes correctly, they should be small, short, and sweet, and we're not going to be making very, very large projects. Classes individually. The complexity comes into the combination of them. All right, so give me an idea here. At the end of the class, we're going to be learning design patterns as we go. But here's the difference with this class versus the 450. And if you haven't taken 450, that's okay. There's no bad habits to break. You're going to learn not only the patterns, but how do you use the patterns in a real-time environment? A lot of the design patterns were structurally correct, but from an efficiency, from a speed perspective, very inefficient. So we're going to twist those patterns around and make it much more elaborate and more faster. So we're going to take the core of the patterns and start to crack them apart and see how we can make them run faster and understand the runtime limitations associated with each of the patterns. Another thing that's going to be a little bit different is we're going to take a pattern and create a class that sometimes we'll use 3-4 patterns at the same time. So this method behaves like a factory. This method here is acting like a singleton. This method here is the receiver of an observer. And it might be one class, but that one class is actually striding 2, 3, 4 patterns. And when you start seeing people use design patterns at first, what they're going to start to do is you can sit there and almost take a textbook and say, there's the factory, there is the command pattern, there's the strategy pattern. Look, the word says strategy. And when you start to see it in use in real code, it becomes less and less obvious. It becomes less and less in your face that this is a pattern. You're just going to see inheritance, you're going to see abstract methods, overloading certain operators, and that really is the pattern, just getting down to the cornerstones of it. All right. So we're going to make Space Invaders from scratch. And you're going to write every line of code for Space Invaders. But what we're going to do is write Space Invaders using this modern style, modern techniques. And I want to show you a student. What we're going to do is just use old video game of Space Invaders. If you haven't seen the game, there's emulations you can go try and play. There's videos from the arcade, but we're going to basically simulate exactly the original arcade game. And the reason we do this is if you made a project or if you made a game, every time you hit an obstacle, you're like, oh, I'll change my design. So if you look at like a lot of game design programs, they're hilarious because they all come up with this big ideas like, I want to do this, and then I want my character to do that, and all these different things. And the first time they start coding up something, they get into trouble, and guess what they do? They just change their problem, And by us copying an existing solution, we're like, this is the standard. We cannot change this. We can't modify from this. Now we have to force the deal with the design and try to architect a solution for the known problem. So here's a student who did it. So here's his design. So everybody's going to turn in a design document, and so here's his design document. So it's going to be, you design, and you have to kind of cover your problems, your challenges, your design patterns for for this system. So here's object pooling. Here's singletons. He sketched some drawings, flyweight pattern, and you can see he gave a little icon for his page numbers. Command pattern, composite pattern. So he goes deeper into null objects, factories, state patterns. Goes in visitors and other things. So, so here's this documentation of how this works. And we've seen a lot of different ways people communicate their design patterns. And one of the things here is I've had probably 20 students who go to a job who's gone to the, sorry, I don't know if this was the right call doing that move. I had 20 students or so who've interviewed at certain companies, and they would bring this design document with, and they would sit there and quickly just sit down and talk with the person interviewing them. And it was like, oh, by the way, I did design patterns, and they sit on the table. And I tell them, don't say anything, just set it on the table. And the interviewer can't help but pick it up and start looking at it. And eventually in the interview, they'll be asking you questions about the design doc, and suddenly you change the narrative of your interview. Instead of being blindsided by questions you can't control, you're getting asked questions on stuff you already know and that you wrote about. And quickly, most people in this scenario actually know more design patterns than the actual company they're interviewing at. So it's kind of interesting. I had this one group of former students. They all interviewed at the same company, and the first thing they go is, "Where's your design doc?" And there was like 8 out of 8 students got 8 jobs right there from that design doc. All right, so here's my one student's review.
Hello, it's Justin here doing my 15th attempt on this silly video, my final video for Space Invaders project. I just keep having some issues. My demo screen, like the self-playing demo screen, for some reason that likes to crash only when I'm recording. It doesn't seem to crash if I've let it run for 20, 30 minutes. It won't crash, but the second I start to record. And then I had an issue the last time, it keeps happening right at the end of my video, where, the window, and you'll see we start with the kind of, you call them attract screens, kind of animating and trying to get you to put in your quarters, right? So each one of these are all controlled, everything's kind of became controlled by the scene manager. That's the main thing that controls what we're seeing and what's going on. So these are all different game scenes. Each scene has a couple different things that it has to have. There's the game scene main class, and then all the inherited classes. They have to have an initialize, which is sets up the scene the first time. They have a transition, so anytime you go into that scene, it's things that fire off. And they also have a switch scene, so anytime a switch scene event is called, which usually is called from the timer manager, it knows where to go. And it gets a bit more complicated with different states, like 1 player mode, 2 player mode, the current player. All of those are controlled with different states in the game manager, but ultimately, it's the game scene calling that. So let's see, how do I do this? I made my font sprites. They're animated. You just do font sprite.animate, and that cuts up the string and puts into a bunch of different timer events, so you get the animation there, which is cool. I recorded my gameplay. I just recorded myself, my keystrokes into a binary. So every game scene has its own custom input handle, or rather, so the game scene base class has virtual functions for different inputs. So there's if it's left, do this, and then you override it in the scenes that you want to actually enable it in. So pressing left or right in this scene does nothing, but when you play the game, it does something. So there's that. So I kind of recorded my keystrokes, and I gave the demo. This is just a normal gameplay, slightly modified. I made the score modified, and then one other thing. But sometimes he'll die in the demo, and sometimes he won't. But if he dies, it just changes scene, and that one. But when you die, I want the aliens to pause. So it actually worked out really, really nicely, and it wasn't too much extra work. All right, we'll watch this guy, and then we'll start up the activity. The aliens are all coming down, doing their thing. I'm gonna get rid of some of them, or else being pretty annoying. You'll see they're leaving damage on the floor and on the shields, kind of like the original. The way I did the shields, I want to redo it. I had a different idea, but it was kind of gotten to the point where I haven't done time the shield might be.
So you can see here's the the boxes of the actual targets that we're going to be shooting at, and then as the missile intersects these boxes, then a collision is detected, and then you do the appropriate reactions to that to remove the thing, add score, just create a death scene, remove it off an active list, and then recycle it. So you can kind of see this stuff. It's going to get pretty detailed pretty quickly here. So I hope that made it through the video. All right, so that's the big project there, and like I said, again, it'd be about 130 classes, 150 to 100 to 150 classes, and over 12 design patterns we'll be using. Right. So
Just so you know,
yeah,
what's a bit laggy? Just so you know.
it's the upload. I'm sorry about that. But it will be snappy on the record. So everything should go slower now because there's no more video. And hopefully, if I pass my COVID test, I should be in the States next week. So everything should be much better. All right. So one of the problems right now is that this is a large project. And no matter how I treat this class, there are students who aren't disciplined, who don't stay with this stuff. This class is one of those snowballs. The ball starts rolling. You're like, oh, it's easy. And it gets bigger and bigger and bigger and bigger and bigger to the point where it's impossible to finish if you don't stay up with it. So to kind of encourage you to stay with this program, I'm doing weekly check-ins. So we kind of have two simultaneous problems going on. One is sprints, and one is our programming assignments. So we can think of our programming assignments are little chunks of code. I'm going to give you problems to do, design patterns to do, and it'll have unit tests, it'll have sample code, it'll be a little standalone project. And you're going to code that up and kind of get comfortable with the format, the mechanics, stickiness of certain areas of the problems, so you can kind of microscopically focus on those. Then what we're going to do is take that knowledge that you learn from that and constantly integrate into a larger project, which is your game project. And your game project is going to be, basically you're making Space Invaders from scratch, and you're starting to use the patterns as we discuss in class, and you start to integrate those. And to keep you up to date with that is every week you're going to do literally a 1-minute video of your progress on the on your big project, your sprint. And basically you're just going to do a video, show off some of the features, do commentating, but it's 1 minute, so it's really quick and dirty to see it's there. You get a check, no check kind of assignment. And this is to give you external pressure. I can sit there and say, hey, in 6 weeks, there's this big milestone due, and sadly, and I have 10 years or 15 years of historical data on this, half this class will not do it until the week before, and success rate is 0 after that. So by giving you every week, this is kind of a little checkpoint to keep you pushing, keep you working on it every week towards the big project. So we have weekly design patterns and coding samples with unit tests. And then we have weekly check-ins of your sprint to show where you are in the progression of the game. At week 6, we have a milestone. And this milestone is the reality sandwich milestone, which is you need to have this many features working done by this date. And basically what it is going to be the whole alien grid, that 5x11 grid of aliens marching and animating, going back and forth across the screen, have to be running with 4 or 5 design patterns at week 6. So that's milestone 2 and milestone 1. And then everything else is due at the final week. And the final week is the big project where we go through a whole laundry list of features for the game. And this is right from the video references. Let me give you an example of that. So, this is kind of the sample. Of, that's this one. Um, there you go. All right, so here's the final like deliverable, and you can see like which design patterns you're using. Um, you check the ones that they're using, and then here's all the features of the game. So it just keeps going and going and going and going. And each one of these you have to demo and show off. Yeah. So that's kind of the final deliverable. So we're basically just checking to see how complete is your game. Are you using the design patterns, and then you'll have corresponding UML and design doc to go with it. All right, so so some of the features we're going to go through. It assumed you know nothing about video games. This is not a video game class. This is a design pattern class, and we're just using the video games there as a vehicle to force you to be precise and exactness in your design patterns and your mini problems that we're implementing. So some of the design patterns we're going to go through are singleton factory, null objects, flyweights, state, strategy, observer, memento, facade, proxy, prototype. There's a lot more that are kind of going on there that we're going to get deeper into. We're going to create everything from scratch, which we're going to get as a very basic game environment. And then from there, we're going to build everything up incrementally, almost like a Lego set. We're going to get small little basic building blocks, and from there, we build more complicated building blocks. And those complicated building blocks we can snap together and make even more complicated behaviors. Sorry about that. All right, so the programming assignments, there'll be one a week. And there'll be a unit test. I just created a whole unit test for this, for C# for this environment. And, it should be pretty self-explanatory. We go through that. And this is just to get your design patterns built up from scratch and a way to verify that it works correctly with a correct behavior from a real-time standpoint. Sorry about that.
Do we create the unit test or do you?
Oh, I do. Yeah.
Okay.
I wish you can do it. You're going to have their framework. If you want to create more unit tests, you totally can. The unit tests, have you taken Optimize C++?
I'm taking it right now.
Okay, yeah. You'll see. I don't think many people can write unit tests.
I write them, but in JavaScript and Python. I have not done it in C#, which is why I asked if we were going to do it here.
I welcome debate because I'd love to talk to you about how you're doing unit tests. The reason why I say this, my grad students in my more advanced architecture courses, I give them one assignment where they have to write their own unit tests. I don't give them anything. Like kick off the training wheels, like here you are, here's a project, do it without my guidance. And it's a disaster. So
they must have not read the book Test-Driven Development.
Yes, I know that one. Mm-hmm. Yep, I think we choose some of the same ground, so it'd be awesome debates. All right, so but you can add more unit tests up to you want. I just have a minimum stuff just to make sure we feel comfortable with it. The sprints are just going to be like, here's features, and what I want you to do is to implement the certain behaviors and certain steps as we iteratively build our project. And what we're going to do with that is we're going to, you'll start seeing like, here's a problem, like how do we spawn one alien but use it 11 times on a row without creating 11 resources. So what we're going to be doing there is we're going to sit there and create a factory to spawn off the alien. We're going to actually only create one alien, and we're going to use proxy objects to hold 11 places. So all we have is 11 objects that have a minimum load that point to a more full-featured object. So we use proxies for this, and then we're going to attach those alien objects into a two-dimensional grid of the composite pattern. And the composite pattern is going to hold all the aliens. And then to move all the aliens, we're going to actually add iterators to the composite patterns and then hook that up into a priority queue to do the movement. So you see something as simple as put an alien on the screen, and suddenly there's 10 problems we have to solve to make this work cleanly and efficiently. And so that's kind of the caveat we're going to be doing with this. So these are all step by step. We'll kind of go deeper and deeper and bigger into this. At week 6, it's kind of just a real milestone that's a little more deeper than 1 minute checks that you're working. And this is where you're going to have to demonstrate and show off the functionality to this point. And this is just a grid of aliens, so 55 aliens, 3 different types of aliens. They're all animating, moving in unison together in a grid pattern, back and forth across the screen, with the appropriate cadence and animation. So this is what we're going to do for like milestone in the 6th week, just that we kind of get this. Now this class is kind of interesting. It builds slowly, and then it starts to take off. And it's right around week 6, week 7, we start to add 1 or 2 more patterns a week. And suddenly now we're enabled to build more and more of the game, and the game starts coming together very quickly in a data-driven way. Right. So this is a project-based class, so at the end of the day you're doing one large project. And so this is just the specs on how to make Space Invaders, all the different things, and making sure we're using the same nomenclature, so we're all using the same words. The interesting thing is Space Invaders itself is machine code. You can actually Google it and get all the source code there. And it's in a big glorified for loop is how they make it. A lot of times people didn't realize this, but you know how the aliens are marching back and forth on the screen. As you shoot 1, shoot 2, it goes a little bit faster, a little bit faster, a little bit faster. What happened in the original arcade game is they were so many graphical objects and items that were keeping track of, it was slowing down the CPU. And as you shot them, the CPU was able to run faster and update faster. So as later processors came out, they had to emulate the speed increase. So the speed is proportional to the number of aliens on the screen. So that's why when you get down to 1 alien on the screen, it's running pretty fast across the screen, zipping back and forth. All right. So some of the components we're going to do, we're going to be doing a lot of different systems and components there, and these components are going to be basically pieced together with different design patterns and different modules together, and then that component then becomes a system that we can reuse and interact with. So we'll be doing the input system, the animation and sprite system, so we're going to have a way to animate and give the illusion of animation. We have a collision system, and the collision system we're not only moving objects around, seeing if they intersect, but also dealing with the reaction between 2 systems. I give an example of this. This turns out to be every single game people play. It could be a simple iPhone game or an Android game, or it could be something more advanced on the Xbox or PlayStation. You at some point shoot something, hit something, drive into something, you create a collision. The question here is, if you're running down the street and a car hits you, did the person hit the car or did the car hit the person? And who reacts for that? And it turns out actually it's a more complicated problem. Where's the ownership? When it's a human hitting a car, does reaction to the collision happen off of the human. Now does the human have to know what happens when he hits a car, when he hits a tree, when he hits a bicycle, when he hits, another human? Or does the car need to know what happens when the car hits a human versus a bike versus a dog? There's these things about who owns this. But now let's make it even more level. These are two agnostic objects that we don't even know that they are a car. We don't know it's a human. And now those two collide. So now you just have object A versus object B. Now, what's your reaction? How do you react between those two? What happens? What's the result from this? Who owns it? It turns out, actually, this turns out to be a very interesting problem about ownership, discrimination of who collided with whom, and how to create the interactions cleanly. And for that mode, what we're going to be doing is we're going to be using a visitor pattern in double dispatch in reverse to actually discriminate and get into the actual combination of the two objects that are colliding. So it's kind of an interesting little problem. The shield, we have some similar collision problems. We have the shield getting collided. Sorry. And the shield can be collided from the player at the bottom shooting up missiles, or the aliens could be dropping bombs from the top. So you have the erosion of the bricks going from the top down or from the bottom up. And then you get into really interesting scenarios where at one moment, because it's all programmatically generated, a brick was deleted by the human's missile, and it was deleted by the alien's bomb. So how do you have two collisions, because you only can collide once, and how do you remove it once without removing it a second time? And both systems don't know what the other system's doing. So the right hand doesn't know what the left hand's doing, and you have simultaneous collisions. And also you have a scenario where you have missed collisions. If the missile's going fast, you can actually move in such a way that you miss the actual intersection of the collision. So we'll go through that as well. We're going to make a font system, a way to display strings and text programmatically to the screen using glyphs. We're going to be also creating a sound system where we basically control the different types of objects, the different types of behaviors with different sounds and different reactions. I'll give you an example of this. We have why aren't you playing, buddy? There you go. All right, so there's that. It's just bogging pretty hard, but basically we had this drum beat, dun 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 dun, and those are different sound effects. And every time we move the alien, we animate the alien, we strobe it, will advance and play a progressively more drum beat music. So kind of think of like those old pirate movies where the guys are in the bottom of the boat rowing, and there's a guy with a drum, row, row, row. That's how we're going to get the sounds to play for the marching of the aliens. And then we have this all the original sounds for each of the features and effects of the engine. All right, so the design pattern, you're just going to describe how it designs, and what you're basically going through is, and what we'll have is you do one design pattern during week 6, so I can give you feedback on how to do this. But what we're basically going to do is identify the problem, which pattern do you think is appropriate to it, how does the pattern improve or solve this scenario, and how are you actually using it in the environment. So this is more or less the proof that you've done this yourself. You understand how to apply the patterns. So unlike a lot of classes where like here's a laundry list of design patterns, you're actually going to use the design patterns in the actual applications and see how it's being used. We'll be doing all kind of UMLs. You'll be really good at the end of this class with UMLs. All right, we're going to use everything on Perforce. So Perforce is pretty straightforward. It's just a repository. I'll geek it more than that. And you'll submit things in there. Every sprint will be its own directory. Every PA will be its own directory. What's nice is you can check in stuff to Perforce. You can sandbox into Perforce. If you screw things up, you can go back to Perforce and undo. You can undo your changes and kind of get back to stable ground. All the notes and everything will be on Perforce. So Perforce is our repository that holds all our data. All right. We're going to be using Piazza heavily. I'm also going to enable a Discord. Piazza is the sanction kind of environment. So ask questions there. If you use Discord, it's much more free form. It's almost more of a social platform in a lot of ways. But I suggest keep asking questions on Piazza. In the past, I've had over 7,000 unique posts on Piazza. We can argue and articulate and get a lot of things shook out on Piazza. You can also post in Piazza privately if you need to. One of the nice things about Piazza is you can put snippets of code, you can put UML diagrams, and it's a great little things to tease out an exercise. What I'll do over time is ask questions and start to kind of get everyone thinking in a certain way, or try to challenge your rationale behind certain things. So we'll have debates going on there. So you can saw like earlier today, I asked about encapsulation, and that was kind of a nice discussion to kind of get going. One of the things here is as you start to master the material, you don't realize how much you don't know until you try to explain it to somebody. So you might do well in a class, well with the material, then try to explain it to a colleague, and you realize you're fumbling. That means you just don't understand it as well as you thought you did. So if you understand this, then help somebody else out and explain it. And by just explaining it, will solidify and clean up your logic. It's really good. All right. I'm a big believer. I'm a big anti-group person. I was an undergrad. I was a grad student once, and every time you work in groups, I wound up carrying the lion's share of the work because I didn't either trust the other students who were with me, or they were lazy, or they just didn't do anything. They knew somebody would do all the work. And so this class is 100% you. You work on it. It's all yours. Everybody's project is so sufficiently large and complex, they don't look the same out of each other. But it doesn't mean you can't work with each other. You can't bounce ideas off each other. You'll see a lot of my code. I'm going to be coding the whole project with you, and I'm going to submit all my code up on the repository. So you'll see it as we go. It's there to use as a reference. So here's how this class typically goes. Students kind of land in one of three categories. They either try to do it in parallel And then they look at my answers and say, okay, that's how Keenan did it. Sometimes they like what I did, sometimes they like what they did better, right? So one is you're kind of in complete competition with me, and you're working on your project, and you're using mine as kind of a checkpoint after the fact. Another thing is you're gonna work on yourself, and then when you get stuck, you're like going, well, how did I do the mechanics? How did I get the code to work? And students are going to look at my code and get influence. And like, oh, that's how I got through that sticky part. Yeah, I don't know if I would have figured that out. And they're going to borrow, lean, look at my solutions to influence their solutions heavily. And then the third approach is mimicking. You're literally going to take the code that I do, take it in and try to understand the code I write, modify it, extend it, and massage it into a solution that you need. And this is going to allow you to, this is mimicking. So if you think about it from an art standpoint, when you first are learning any kind of art, first thing you do is you mimic. The second thing is you embellish, and the third thing is you make your own. So any of those pathways is completely fine for this class. A lot of students feel a little bit weird because they're like, well, I started doing my own way, but I kind of came back to the way you were doing it. Like, oh, that makes sense. I'm doing it a certain way, based off of logic. But as our project gets larger and larger, your code's going to look more and more different. So I'm not really worried about people cheating or doing this stuff because the projects are too large. Every year there is at least one or two students who think they're going to out-geek me, and I'll just see them in integrity court. I definitely have tons of tools in forensics, and I used to be a software consultant for the federal government, so I can analyze code. So just don't copy somebody else's solution. I will find it. Also, I have every solution for the last 15 years in my repository that I cross-check. So that's another vote against copying. Right. What else? Oh, people were it's really weird. People ask about late policies. If nothing is late, you can keep changing and checking in until I grade it. I will not grade it before the due date. But if something happens and I take another 3 days to grade or another 2 weeks to grade, and you manage to get your submission in during that time period, no hit, no foul. Whatever's there right before I grade, I grab all the version control, and then I grade the stuff right there that day. But if you're past that date, past the day I grade, tough rocks, it's a 0. There's no partial credit, life's mean sometimes. So just get it done in time. This class really isn't, is pretty easy to stay on top of. As long as you keep working on this stuff a little bit every day. And then we have the big ticket items like the milestone one, which is week 6, and then obviously the final project, or big deliverables. Everything else is really small amount.
So instead of a midterm, is our that milestone our midterm kind of?
Yeah, you can think of it as that. There's no final. There's no exam. I used to give a final exam on this class, and it was really kind of give you the background on this. I used to sit there and say, here's 10 patterns, and I would obfuscate them. Tell me what the pattern is. What does it do? Why does it? Why do you use it? Right? And it was really weird. The students who finished the whole project, they got 95 to 100% on the finals. The students who didn't finish the project got 30 or 40% on the final. But they got 30 to 40% on the final project anyway, so I didn't see any wisdom of putting people through a final exam and the stress when it has the exact same correlation of whether or not you can finish the project. So I found no benefit from it. If you want a final, I can give you an old final just for fun and for yucks. but it gives you no inherent benefit. By you doing this, you understand the material better than, like I can, I don't know, it's like Karate Kid. If you keep doing the same wax on, wax off 100 million times, eventually it's in your brain cells and you just have muscle memory of how to do it. If you do your strategy pattern, observer patterns, visitor patterns, all these patterns, and you code it from scratch, you go through the hell of doing it. You understand why it's there. You understand it better than me just asking you, like, oh, here, do a UML diagram of this. Of course you can do a UML diagram of this. So I found that the finals have really no bearing for this class. Does that make sense?
Yes, thank you.
All right, so one of the problems. Sorry. God, I don't want to be here another week. All right, so one of the problems is make sure your project doesn't crash. So as we're playing it, testing it, make sure it's robust, it's working, it's not crashing, and it's exiting correctly. If it crashes while we're trying to evaluate it, I can't create it. If you do any type of cheating in any shape, way, or form, it's a full letter grade F. There's no partial credit or anything like that. All right, so here's the schedule. It's kind of straight layout. Every week is a sprint. Every week is a design pattern or a section of code to do, and we kind of grow this stuff out. Jeez, sorry about this.
Is the syllabus anywhere that we can see it, or can you show the header of this table once more?
Yeah, I'm going to all this stuff is going to be posted.
Thank you.
Yeah, this will all be posted in the week 1 lecture notes, and the syllabus will be posted up on the D2L.
Thanks.
Yeah. But the material as we go, I'm going to be pulling from multiple references, different books, different material. Sometimes it's one of those things where some of the patterns are described better in one format than another. Sometimes you want to see it 3 or 4 different ways, and somehow through the combination of seeing that, then you start to kind of get how the pattern works. Then also watching and seeing my coding demos to do this stuff as well. All right, that's about it on the syllabus. Any questions on it? So you will code a lot. If you talk to anybody who's taken this class, they'll definitely tell you code a lot. But it's easy coding. But at a certain point, and it changes for each person, but something happens along the way that you kind of get bit by the bug. You get excited. You want to see your stuff looking correctly on the screen, and you start to code deeper and deeper into it. And then, if you're 90% done with a programming assignment, but if you see it graphically missing, not behaving correctly, you'll spend the extra time to finish it off to make sure it's done correctly. And that's what that video game portion brings to the table. It's a very good motivator to stay with it, to hang in there, to do it right. Or if you get something working, can you do it better? Can you do it cleaner? So you might do it again. And I found that the video part kind of drags you through that. All right, so what I want to do is quickly get into doing some code and kind of show you some low-hanging fruit here, some UML stuff. And the idea here is that we're going to be coding everything in C#. So let's maybe go through a C#. No, let's do patterns first. Go patterns, and I'm trying to think of what's the best way to do this. We'll do UML. All right. So UML is a unified modeling language. It's just a way to communicate, and and the idea with the UML is that you can communicate a lot of complexity, a lot of nuance, quickly in a agreed upon structure and layout. And so what we're going to be doing. Yeah, PBX, okay. There you go. So there's different types of documentation. You can do source code documentation, or you can do whole design documentation. And one of the things here is you see source code documentation. People might have seen Java Docs or Doxygen. They might just put comments in their code blocks. That's source code. The problem really is I had a colleague of mine that he was a hardware engineer, and he had this really interesting question. He said, how do you know that you documented your code well enough? And so we're sitting there talking about this, and he said, if I delete every line of your code, and just from the comments left, you should be able to faithfully reproduce the functionality. It might be implemented slightly different, but it should more or less do the same function. Then you documented your code well enough. The good news is, doing design patterns and doing these small little classes, the classes are so small they're almost self-describing. Too often you see people write comments in your code, and then the comments don't match what the code does, because like somebody changes the code, modifies the code over time, and the code actually drifts away from the comments. And the comments might be actually a confusion or misleading, because you might read the comments and you're like, oh, the code does this, but then you look at the code, it does something else. So if you just skim the comments, you're like, oh, I get what this is doing. You might be 100% wrong, because that was the original documentation, but the code has evolved and it isn't doing that anymore. So I found that actually source code documentation, kind of the problem goes away the smaller your code is and the cleaner your code is laid out. Renaming a function, renaming a class correctly probably will give you more proper documentation than you would get with somebody documenting the code traditionally. So so that's one thing. It's like source code I don't think is as important, but whole design. Why are you doing certain things? Your philosophy. How do you put things together? That's more important. That gets into your overreaching structure. Why are you doing it this way? What's your kind of scheme that you want to repeat again and again? So UML is just an agreed upon standard, and this is used a lot. There's class diagram, sequence, use case, all kind of different schemes, and some engineering places take this to the extreme. They'll sit there and try to say, you know what, I can do my whole design in UML, hit a button, and it generates code. And every single company and project, Rational Rose and all these ones that do this stuff, it ends in a disaster. We need to use the diagrams there to communicate, to argue, and to debate our designs. Trying to have it generate the code gets too micro, too granular. If you have a class that has 25 variables, now you look at a UML with 25 variables in there with 25 or 50 functions, it just gets noisy very quickly. Where technically what you really worry about is these 3 methods. And these 2 or 3 pieces of data are the key data from there. And the rest are just supporting cast members, so you don't really need to highlight that. So diagramming and know what to add in there and what to omit is probably part of the art of it. So probably the most important part is class diagrams. This is just to tell you the properties, the variables, some of the methods and constraints of how things are connected together. So here's one that we did from industry, years ago when I was at Midway. Here's the animation, and you can kind of see ownership. You see aggregation, you see composition, you see cardinality, quantity of things. This little diagram here has a lot of communication associated with it. And this by no means is the whole class, but we can sit there and put this on an overhead projector, and a number of software engineers can sit there and argue and debate about this, and why things are designed the way they are. So one of the things here is the concept, and this to me is an interesting thing, and this is, I think, the key to architecture is ownership. Who owns which object? At any time, you should point to any class and say who owns it. Who's responsible for its lifetime? Who's responsible for the creation of it? Who's responsible for the destruction of this? And this is independent of which language you use. You need to understand ownership. So composition is a critical thing. So here a car is composed of the engine, or has the engine as part of it. So here you see the car, and there's a black diamond, a solid black diamond, and that says I own an engine. And so what this means is the car is responsible for the engine. So the car would either created the engine, or somebody else, a factory or somebody else, created the engine, and now is attached to the car, and now the car now is the owner of the engine. So if we crush the car, we also have to crush the engine. So this idea of composition is important. The problem here is there's no mechanics in language to do composition. So we can create a class. In this case here, you see the code there. It says car, class, and then it says engine, and we create a new engine. But there's nothing to tell you that you own it. There's no mechanics of this stuff. So I come with a convention that this right here, the car will have. Let's see if this works. No. I don't have my marker board. So basically what it is the car owns the engine. So I'm going to do a convention later with naming to show you how to do ownership. And what I'm going to do is I'm going to use the word pointer own. And we'll get into that when we get into code. But so anyway, the big thing here is black diamond means ownership. Think of this as a person, right? Owns a dog. So they own a dog. If the person dies, then the person is responsible to do something with the dog. So they'll either, in a grim way, you kill the dog. So when you die, it's a big Egyptian burial. Or you basically, when you're about to expire, you transfer the ownership to, say, your brother, and now your brother owns the dog. This is a ownership. So the car is responsible for the lifetime of the engine. An aggregation is a has a or referencing to. So basically, a person can have a reference to an address. It can point to an address. A person can point, to a book. A person can point to a lot of things. If the person dies, they're not responsible at all to kill or delete or to move what it points to. So aggregation is has a relationship. It's kind of a loose connection to it. There's no concept of responsibility. So we have composition has ownership. Aggregation doesn't have ownership. And they also, in UML, if I'm going to get all super technical in there, they have minus signs for private, pound signs for protected, and then plus for public. That's kind of a minor thing. Inheritance is an open arrow that points to. And the way to think about this is A is the parent class, B is the child class. And the arrows are really important. And the way I think of this is you're at a party and you have a young kid is at a party with their parents. They're always, when they're separated from the parents, they're pointing towards their mom, trying to point back to their parent. So the child points to the parent. We can sit there here and say, animals is the base class, the drag class is dog or cat, and they point to the base. So it's an open arrow. Dependency is it's just an arrow. It says I depend on or use, and it's just it can be a solid arrow or a dashed arrow. It just shows dependencies. So this just shows you that a car is going to be is uses a gas station or depends on a gas station, so it has to get gas every once in a while from there. And A class is associated and uses the B class in some fashion. Carnality gives you the counts. So you always go from the base of the class. So a car here has 0 to many. So there's 0 to an asterisk of, I'm sorry. Go from the ownership, sorry. City points to cars. So the city doesn't own cars, but a 0 city to 1 city owns 0 to many cars. There are points to or associates 0 to many cars. A car, one car can have 4 to 5 different tires. A car, in this case here, uses or depends on a gas station. So this gives you this ordering. Just tells you how many really quickly. So we can take that, but that's the major use for what I found for a lot of UML is until you get into protocols like networking protocols, security protocols and stuff like that, you, for the most part, the utility of a UML is just to tell you about the class ownership and class connections. There's also sequence diagrams where you basically kind of flow through, and this is like the whole communication protocols back and forth. So you start from the top and you go down, and it's going, you start from one side and you go back and forth, back and forth, back and forth, and then you arbitrate, and you kind of get your package or your communication. So this kind of gives you a little bit of state to show you the expected interactions. There's use cases, which is really typical, where you have objects and you're like, okay, from this perspective, what can I do? I can do this. And then from that perspective, what can I do? And you can kind of go through this stuff. So like you'll never be able to do a withdrawal from a bank until you registered as a user at this bank. Make sure you have an account at this bank. Make sure you have enough money in this bank. Now you can actually start to start the transition money from there. So these are different use cases. A lot of times the way to kind of approach this is, what do you tend to do common? What is the approach that is happening 80% of the time? Make sure you have those sequences there and it's on the fast path of working correctly. And then make sure then, okay, when you're starting to deal with more rare events, what state are you at? What state are you going to control these use cases? There's also
question. Should one write the documentation before the code or the code before the documentation?
Oh my gosh, great question. Okay, what's the best way to say this? I'm going to speak for myself. I've never been able to write documentation and then code correctly. And I've been doing this for 30 years.
Hard. It is hard.
No,
but I figured maybe like
the catch is
like maybe the
wrong.
diagram.
You're always wrong. No matter how.
And you always have to change it and update
right.
it.
Yeah. So the catch here is this: what if I sit there and say, I want you to take a boat from Chicago and sail all the way to Norway, right? You're like, okay, well, we'll go to Lake Michigan, we'll go up, through all the chain of lakes, go through Hudson Bay, go into the Atlantic, and make our way all the way over to Norway, right? And you have this all planned out, like it should take me 3 days to get through to Mackinac, and this many days across, Lake Superior, and all this sort of stuff. You have this all figured out, right? And your boat's in the water, and what happens? There's a storm. The storm blows you into Wisconsin, and you're just grounded in the sandbar in Wisconsin for 3 days. Well, I'm glad you made a 3-month plan to get there, because you're already wrong the first 3 days of your trip. So when you try to design your code and your documentation first, you don't know what you don't know yet. So my mode is always be agile, be adaptive, don't be married. And you'll hear me say this. I say this so frequently, I don't even know I'm saying this anymore. Don't be married to your code. The problem here is when we're young and we're learning how to code, we spend a lot of hours and a lot of effort to get our code to work. And then we have this emotional attachment to keep it. And you know what? When you're more seasoned, you'll write a lot of code. And you write a lot of code and you get all this other stuff, and you're like, oh, now I understand why it's broke. And now then you throw away 3 weeks of worth of coding, and now you're starting to approach it correctly. And everybody goes, my God, there's 3 weeks of coding you just did, you threw away. Yeah, but now I'm on the right path. That was all useful work. But the young programmer wants to keep that code because it caused them great pain and suffering to get there, and they try to keep it too long. So don't get emotionally attached to your code. Be comfortable throwing it away. And it's one of those things where you have to have this like almost Buddhist kind of approach where you're just okay with detachment on the code and let it kind of fall away. So the best scenario is start to code. And then when you get a little further into it, you start to understand the requirements more. Then you think, okay, I do this. And you're like, nope, that didn't work. Well, maybe I don't understand the requirements. And you code a little more like, okay, now I understand the problem. And if you ever coded something completely and you get a chance to do it again, your second version is 100 times better than your first version. And that's because you understand the problem much better. So don't be afraid to make mistakes. Don't be afraid to put the boat in the water, and just trust your navigational skill set that you'll adapt to whatever kind of storm comes your way. You can turn the boat. Like I said, I have not been able to design on paper first. I was
Thank you
principal.
for your input.
Yeah, I was a principal architect. So I mean, I would make a design that 100 programmers would follow my direction. So yeah. So all right. The last UML. So hey, COVID has coughing. I don't know if you knew that. Sorry about that. UML has state diagrams, which is standard state diagrams. So you've seen this stuff before. If you want a good article, anything Joel on software is a very good read. His article, he was a software engineer on Excel back in the day when Excel was being created. It's a fantastic read, and it kind of goes through different ways to do specifications. Also, a must read is Pragmatic Programmer. So as I go, I'm going to start poking you guys with books and materials and references. Pragmatic Programmer is one of those books in the industry. I mean, every person in my team read every 6 months. The whole book every 6 months. It's that critical. All right, so here's UML distilled. If you see this book, you can probably find it. There's digital copies out there. There's also the DePaul ebooks. It's only like 90 pages, and it has everything you need to know about UML. I think besides the authors of this book, I'm one of 10 people who bought this book. This is documenting software architects, and basically it talks about how to create your own symbolism and associate meaning to it, and how to create design documentation and visual representation on things that have not been defined yet. So sometimes you're going to get something like, it's not in UML, so how the hell do I document it or describe it? This kind of gives you guidelines of how to write a common what's called, there's a fancy word for this, but basically you can you basically define all your symbols and give the symbols meaning and value and be consistent on a graphical language, and you can start building up your documents from there. All right, so that's UML. All right, so let's design pattern. All right, so here's this quick and dirty intro to design patterns. All right, click, go ahead, buddy. There you go. All right, all right, so so design patterns in good OO design are kind of intermixed, and they're kind of, if you take the core OO principles, you'll start to get design patterns. And one of the things I want to do with this class is a little bit different. Has anybody gone to, I think, it's Ohio? No, it's Iowa State. Iowa State. No. Okay, well, anyway, back in the late 80s, Iowa State had a new engineering quad. And what they did was they had, 8 buildings, 4 by 4, laid out, kind of across from each other. And what they did for the first year is they just put grass between all the buildings. And everybody was like, why are you put sidewalks out there? There's just grass. And the landscape architect said, look, students are going to walk the way they're going to walk. And what we'll just let it do is let it go nuts for a year. And whatever's not grass in the spring, we'll just put concrete there and make it sidewalk. And it turns out certain buildings were, was the chemistry lab. Another building was, the physics lab. Another one was, all these different buildings. And all of a sudden, this one building would have, 1,000 people in a lecture hall, and boom, everybody would fan out. So there'd be all these different, like, parallel lines coming out of there, these, like, rays of pathways that come out of that door. And then this other one was just used for grad students, and it's this one little line coming from the street into this one building. And at the end of the year, they came back and put concrete. And it turns out the pattern's still there today. The roads and the path between the buildings still there because it follows the patterns the students were actually using. So what I want to do here for this class is not get hung up on the design principles and the OO principles. I want to start coding, solving problems. And then week 9 or 10, we'll go through the principles we've been already using. And you see that we're going to do and use and have this inherent understanding of how it works and why it works. And then after the fact, we pour the concrete to solidify it, to say the principles we've been using. So that's kind of their approach. We're going to work this a little bit backwards. So here's some good references. All right, so a design pattern is a reusable solution to some commonly occurring problem, right? So this is just a general way, like, how do you deal with a leaking roof? Well, in an emergency, you sit there and you put a tarp over it. When it stops raining, you peel back the shingles, you get down to the underlayment, you put a new plywood, you put a new sheeting on it, then you you add more shingle back on it, right? So these are just techniques to solve common problems, right? And one of the things here is these patterns are somehow they happen again and again and again, and these patterns tend to have some built-in principles and interactions that tend to almost always work well, always be safe. So they tend to be safe and conservative solutions. So, so think about before, OO, and we'll get into deeper and deeper what is OO. When we used the program, we did functional decomposition. And this is kind of where you would just start to take your code and slowly break it down into step by step by step by step. So one of the things here, like let's say you're going to append a string to a file. You have to first open the file, search to the end of the file, get your string, find how many bytes the string is, copy that string to the file, flush the file, close the file. And you would do all that together in a decompositional way. And the problem there is, it works great. Problem is, you have put all the complexity in this one file. You have to go through it step by step by step, and it's very prone to mistakes. It's very prone to what if the file doesn't open? Now what do you do? What if it didn't flush? What if you asked it to write 15 bytes and it only wrote 12 bytes? These are things that, what do you deal with this, and how would you deal with the side effects when this kind of falls apart? And this is kind of a problem with writing classical programming, is that you get too much complexity and too much side effects in a chunk of code. And what we want to do is reduce that. So what we want to do is understand that your code's always going to be changing. And it's not that it's changing, it's maybe that we don't understand the problem we're solving. As we understand the requirements more, then we keep on changing it. So what we want to do is try to take the areas that change and insulate those, put those in a little smaller bucket. So even if that breaks, only that small bucket breaks, not the rest of the code. We're kind of localizing the problem area. If you were working on your tire, and you're like going, okay, I took my tire, I took it apart, and I replaced the valve and put the tire back together. You don't expect your turn signal to break. You don't expect your air conditioning to break. Because you're working in one area, you don't expect the other areas to break. This is the whole idea, is we want to keep our code in a certain small area so that we make our changes there. If we're going to be a betting person saying what area might break, it'd be in that area. So there's cohesion and coupling. So the idea is how closely operations are related together, that's cohesion. And coupling is how strong is routine interacting with external routines. So our goal is always to keep a routine strongly cohesive and loosely coupled, right? So we want a method, a function, a class to be very, very tight with itself, and it's very loyal to its members internally. But we want it to be virtually independent, where it's not really dependent on external classes, so loosely coupled. So a pattern is just a core way to solve a problem, and we can do it again and again and again. This kind of bag of tricks tends to work, and this is a way to solve a problem. We see this even in electronics. If you needed to power an LED, there's a certain way to put a transistor together with an LED that always works. There's a million ways to do it, but there's a couple key ways to do it to make it work again and again and again, to save your battery life on your device. So these are things, we see it again. Core way to do something, we want to do it over and over. The whole idea of the word design pattern came from the Gang of Four book, and here's Gamma, Helm, Johnson, and Facilities, or I can't say his name. Johnson is actually out of University of Illinois. I had a couple students who taken the design pattern class from him. And I'll explain that in a second, but this is basically the catalog of, I don't know, it was like 27 or 30 something patterns. It's a rough book. It's probably good to take a look at it. They just catalog all these patterns, but it's very hard to understand how to use the patterns. It's basically a collection of papers. And so an interesting side effect for a 16-week semester course down at U of I on design patterns, written by one of the people who basically brought design patterns to the forefront. What they do is they have 4 students come together and they give a talk one week about a pattern, and then another 4 students talk about a different pattern, and everybody goes around the room for 16 weeks talking about a pattern. That's their class. So they don't code at all. So it's an interesting kind of idea. Now, I've had those students in this class, and they said now they understand why the patterns work. So doing it, using it, gives you more insight. All right, one of the nice things about patterns is it really helps you reuse it. So once you solve a problem or do it, you can kind of take snippets of that and cut and paste and use it again and again and again. It's a clean way. Somebody sees that you're using this type of pattern, it's pretty easy to turn around and understand what's going on once you're familiar with the code. Maintainability is really good. All right. So a couple key principles here is we try to design the interfaces, abstract classes and stuff like that. We try to favor aggregation over inheritance. And if anything is varying, we try to put it in its own separate class so we can kind of encapsulate it. That's kind of the whole overarching. But like I said, we'll filter that out at the end of the course. All right, so OO versus performance. Basically, design patterns in OO design a lot of times are at odds on performance. To do something safe and responsible, they're just worried about it being robust. They're just worried about it being safe. Just worried about it always working. And sometimes those are in contrast to making things fast. So this class here, we're going to constantly talk and tease about the differences between doing it, quote, textbook, then how do we modify this to make it performant and make it fast? All right. So there's this next part that's a little bit weird. A lot of people aren't really comfortable with this, inheritance. So it turns out that a lot of people get this kind of, let's see if I think I have, no, I have to do it right this way. We'll just try. All right, so when you have a class inheritance, let me see if I can do this. So totally apologize my horrible thing because I don't have my tablet with me. But let's say you have a class here, class A. This is my fat finger doing this. Class B, okay. What can we say about class B?
Class B is derived from class A.
Right. Is there any other implications?
A is a parent.
Mm-hmm. Has anybody heard the word?
All methods that A has, B will also share.
Also share? So far, you guys are doing great.
B is A.
Well, okay, what was that?
B is A.
There's my hook. Finally, somebody said is a, right? B is an A, right? And that is actually incorrect. Right? So as soon as you talk about this, we like to sit there and say, this is an animal and this is a dog, right? So the dog is an animal, right? But the reality is all we have is inheritance. We have no concept or guarantee of an is a relationship, right? And so I want to kind of talk about two different ways here. So let's say this is a double linked list. Wow, my handwriting's awesome. And this is a node, right? And this is a, you know, this is a dog, and this is a chow, which is a subtype of dog, right? So in this case here, the blue is a relationship. A chow dog is a general dog. So all the behaviors a dog has, a chow has as well. A chow is just a specialization of a dog, or you know, maybe to even maybe I go back to the animal. That makes more sense, right? So a animal, you know, has live birth, blah 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 blah, and a dog is a specialization of that. So wherever a class takes an animal, I can also place a dog in it instead, right? So this is polymorphism. That's some polymorphic. D-link just has a next pointer and a previous pointer, right? And a node might just have data, you know, X, Y, and Z. And is a node a D-link? No. So the inheritance on the red is just saying, hey, all the functionality that you have in D-link, node gets access to it as well. It gets the same functionality. It doesn't mean it's an ISA. It's not used in a polymorphic way. It's just used as implemented in terms of. The reason I bring this up is there's two different definitions, and these definitions are horrible, absolutely horrible. One is called interface inheritance. And interface inheritance is the ISA relationship that, you know, dog is an animal. The other one is called class inheritance, which just says this object is implemented in terms of another object, right? And these two names I think are just poor, right? So we can think of as a linked list is a class inheritance, and a dog, you know, and a poodle is a or polymorphic inheritance, right? What I like to use is the first one is mix-in, the second one is polymorphic. And mix-ins are basically, it's just using the inheritance structure so that we have access to those functions. So when you drive, you have a base class A, and you drive the drive class B from it, B has access to everything A's class has. You know, obviously given scope and, you know, protected versus public versus private, all that other stuff. But just, it has access to everything. It has the access to the data, access to the methods. And what this was called originally was called mix-ins. You mix in this class behavior in from the parent into the child. So this is mix-in. And then the other one I like to call it just polymorphic inheritance. And this is one of the things we want to keep separate, is mix-in versus polymorphic. And the reason for that is there's times that we're going to be doing our design and we really need a polymorphism inheritance. There's other time where we just want the functionality and we're using inheritance just to share the functionality to the drive class. And this is a mix-in. So this is mix-in. Man, yes, my writing is awesome. All right, so there's that. Now let's go.
Is polymorphism the class inheritance and mix-in the interface inheritance?
Yeah, no. Polymorphism, if you want to call kind of like what was traditionally called, this right here is the this is the interface. That's why I said the names are horrible. Inheritance.
And so is the mix-in the class inheritance
Yeah,
then?
class, right. Mm-hmm.
Thank you.
But this is why,
And
to me, it just makes more sense to call it polymorphism because it's an ISA, right? And call this mixed in, and call this one mixed in, and that will keep it straight. For
Thank you.
the rest of this course, I will be using those two terms to keep it very separate. I just when you say interface inheritance versus class inheritance, it's like, yeah, which one's what? It doesn't flow well to me. And this is like standard language. I had to look it up, and I just like screaming because I thought it was wrong. All right.
It almost feels backwards.
It completely feels backwards. And that kind of, I agree with whoever just said that. Yes, it feels very backwards.
interface inheritance, but it may not inherit from interface, so who knows?
No, let's just keep it called polymorphism mixing. Otherwise, we'll get stuck in this like rabbit hole of why the names are bad.
And chow is a subtype,
Terminology.
right, of dog?
What?
Did you see that?
So
Was
okay,
chow a subtype of dog?
what is this is dog, right? Yeah.
Oh, sorry.
Yeah. I
thought
changed
you-
it. I changed it to animation. I mean, animal and dog.
Oh, okay.
Yeah. So dog is a subtype or drive class or child. We have a lot of
Thank
names
you.
for the guy underneath.
And
So this is
Anna,
the idea of how you use it, but when you code it, you don't code it differently, right? You don't inherit differently.
You don't inherit it differently, but it tells you whether or not you can use it as an effective base class.
Got it.
So like I can give birth to a dog, and I can pass that dog into any function that accepts an animal. I can, if I give birth to a node, it's not rigorously constrained to be a D-link.
Okay.
So I'm actually, the contravariance and covariance is actually broken on that, which we'll get into in week 9.
Okay, so
How would you like discern or like discern, oh, not the word.
Yeah,
Basically in C#, how would you be able to tell
there's
the code you can
So-
use this as a base class or you can't?
this is now welcome to software architecture.
Oh
There's
no.
the language doesn't give you tricks, right? So we're going to get into the language in a second, but I just want to give you this example here. So here's a class, right? We'll call this class, node, right? And then open diamond, I'm trying to draw it. Open diamond to A, right? So what is open diamond?
Aggregation.
Aggregation, right? So here's how I would sit there and I would say A, P, A. This is how I would have that variable declared. It's just A is the object and P is a pointer to an A object. Okay? And we'll get into why I use the word P in a second. Now let's do this right here. So now I have a node. Pretend that's a solid black diamond. B, right? So this is a composition, right? So it's a composition. So I would do this, I'll go B is a P O B object. And what this is a pointer to an owned object. So what I'm doing is I'm creating a naming convention to communicate to me whether it's a black diamond or an open diamond. And you'll see that as we go. And just give you a little preview. All right, let's talk about the language and then go right into start coding. All right, so we're using C Sharp. The reason why we're using C Sharp is I have a lot of students who are in C++. I have a lot of students who are in Java. Or C Sharp is the Goldilocks between the two worlds. C Sharp, we are not using any advanced features of C Sharp. We're not using .NET. We're not using containers. We're not using generics. We're not using templates. We're not using properties. We are using C Sharp, where we have a class, inheritance, and methods and variables. That's it. Actually, and you're forbidden to use any more advanced features than that. We're keeping it basic, generic C Sharp. And this way, you can quickly go from Java or C++ right into this language. No issue, no problems with it. Right? So here's documentation. There's some articles on how to transfer between the two languages. There's obviously Microsoft created C Sharp. So the story goes in 2 seconds is C Sharp. Microsoft created a reaction to Java, and they called it J++. I actually watched the court trial live at the Senate, where they were suing, Sun Microsystems was suing Microsoft about the term J++. And so Microsoft goes, okay, well, we'll change the name. And literally during the lawsuit, there's a press announcement that it was called C Sharp. They just go, C, well, we use plus already. Oh, look, there's a pound sign, C Sharp. So Java, C Sharp is basically Java. So there you go. All right, so in C Sharp, everything is derived from the system object. This way you can have garbage collection, you can create stuff dynamically. You have boxing and unboxing. Strings are 16 bits. Structures are value types. You can dynamically create structures, and then they become boxed, and so they become dynamic. You can box and unbox things. You can move stuff from the heap to values and values to heap. You can move that stuff in there. And it involves casting and movement and structure. I'm just trying to go through this really quickly here. So here's an int. This is on the stack, 1, 2, 3. If you sit there and say it equal to an object, basically it creates a space on the heap for the object. It copies 1, 2, 3 into it. Now the pointer points to this object. Unboxing is just doing the reverse. So you taking something, you put it into a dynamic heap, and want to bring it back from dynamic heap and bring it back to a value type. You unbox it, and you basically pull it out, and then we'll release the data. So structures and classes are same, but structures can't be standalone. Structures can't define the default constructor or constructor or destructor. Structures are generally copied on assignment. You can create structures without calling new. That's another little key thing. And you can do inheritance, right? We can print to the screen with console write. That's pretty much it, all right? So not much going on there. So let's look at the code. And this will give us some more example, and then we can start coding. All right, so I'm going to give you, before I forget this and kind of go off in the weeds on this stuff, in your student directory, you have Space Matters. This is your reference design. So if you just go in here, you'll see the word clean me. And clean me is going to remove any temporary files. So when you create a project, it creates intermediate files, temporary GUI, and all this other stuff. So clean me just quickly deletes those to keep it minimal. And if you just fire off the double solution, so here's Space Invaders. This is our project that we're going to base off of. And go into game, And if we just enter main is, here's the launch of it, Space Invaders. Create the object Space Invaders, and we just call run on it, and that's it. And we hit run. And this is just a quick little graphic demo. And if you have your C# installed correctly, you should be able to see this on the screen. And next week we'll talk about how to deal with these graphical images called sprites. And we'll start putting the game together. But this, I just wanted to make sure I show you this. This is, so you just fire off the solution. We're going to be running everything in debug. We're not going to be running in release. For everything we're going to be doing is in debug. That's it. So there's not much there. This is the whole game. This is the framework I give you, and then we're just going to build this out and make this bigger and better. We'll talk about that next week. But I just want to give you a quick show. All right.
You said it's in our
student directory.
How do we get there?
Perforce. You have to install Perforce.
Oh, I see. Gotcha.
Yeah. Perforce. If you're not on Perforce, you can't start the class. So, and then what I'm going to do is in Perforce, under reference, I'm going to have on the lectures, I'm going to put the lecture up here, so the lecture 1 will be up here, and you have access to all the notes, everything I do in class, all the sample code, all the PDFs, all the PowerPoints, and then the assignments will be pushed into your student directory, and then also be up here. So a clean copy is always in reference. So reference is your read-only directory. Your student is your working directory, so you do all your work in your student directory, and that's really it. And then
where do we find the lecture, the one that you had?
It'll be in reference. And it's not there
Well,
yet.
oh, okay. Thanks.
It's not there yet, because I put it after, because if I do demos, I want to make sure all the demos and all the lecture and all the notes are there, so they're all consistent.
Okay.
Yeah, I tried a couple times putting it up ahead of time, and then I added material, I removed material, it wasn't consistent, so I do it always after the lecture.
Okay.
I'll be there tonight. All right. All right, so C#. All right, so here's C#. So here's a quick demo, kind of show you some features of C#. I found this is all the features I needed to know for C# for the whole project. So there's not much there. All right, so the project starts from a class, so you have a namespace. This is a namespace, so ours would normally be like unit tests, or it'll be Space Invaders, will be a namespace everything lives on. And then here's your class, and there'll be one program called main, and that's the start of it. So I start with main. All right, so there's system.console. This is your print statement. And you see right here, it's right here, console print. And I think this is kind of goofy to look at the print over here. So I tend to use the next line. Boom. Oops. Get out of here. What is going on? What is it?
I don't seem to be able to access this.
Because I didn't give it to you. This is my demo I'm doing now.
I don't seem to be able to access my folder.
Okay, not the time or place right now.
We'll
talk about
sorry,
that.
I thought that's what this was.
No, we're gonna be coding. If I ever can get this working. Oh, I know what it is. It's this stupid. I have a touch screen that I normally have disabled. All right. Breakpoint. All right. So here's our when you use the system.diagnostics.debug, this will give you a print to this output window here. This output window initially comes in with all these settings here. So if you go into output window while it's running, you can click, and what you want to do is turn off all these all these options here, and just keep just the program output window on. Program output window. Right. So here we go. Okay, so here is x equals 5, y equals 10, and then I can do the using directive. So using system diagnostics or system, I don't have to write the word system in front of it or the word system diagnostics in front of it. So I always start off with using these two using directives. This kind of shortens my typing, so I don't have to type out the full name. All right, so here's the console, right? So we print the line, and so there it is, it prints 5, but I tend to do almost everything in this window, so I just use debug.writeLine. And this is your parameters. This is 0, so it takes the 0th one. This is 1, it will take the one over here. And so there we go. So there's that. So here's a structure. We can declare the structure on the stack. Boom. And then we can initialize it and free it. Initialize it. And then we can print those out. So here they are right here. We can take a structure. So let's look at the structure here. Structure is down here. So here's the structure. Here's the two variables. Here's the constructor.
The print thing is just indexed, right? So that's index 0, which is your first argument, and index 1, which is your second argument.
Yes.
Okay.
So yeah, this is with WriteLine, you can actually index into it. If you don't want to, here's another way to do it. And it's whatever you're accustomed to. I like this WriteLine because it's a little bit more printf like, but you could do this. Boom. Oops. And then plus pos.x plus, and then quote. You can do it that way. And then, oops, plus, oh, that's right. So these two lines should give the same result. There we go. Down here. See, I just have to kind of correct the spacing a little bit. So these two lines here are the same. See. I personally, this just is like, to me, this just seems like a nightmare to put all these, break this up. I'd rather have the index into the argument listing.
That's just an argument of any type. It's not like printf where you got like
Right.
your decimals, x's,
You're right.
y's.
It can
Okay.
be anything. Yeah, it will.
Got it.
It will try to interpret it. Right. So this is a structure, and this is how to print. You can use write or WriteLine. There's a command WriteLine. WriteLine puts a new line at the end of it. You would have to then add a new line to it. If you want to use write, that's all. If you want to take a structure, you can sit there and declare the structure on the heap. So let's do that. All right, so here it is on the heap. And what this is going to do is it's going to code the constructor, a specialized constructor taking 1 and 2. So we go into that. Here it is, 1 and 2. What for the people who are new to Visual Studio, just start exploring. They have here they have windows, and you can sit there and say, look at the autos, and there's your variables. It's pretty self-explanatory. Or just ask questions on Piazza. You can kind of get through this.
Are autos variables?
The auto guesses what variables you want to look at. So it says, we think you want the P position, so we'll give you those. You can open it up, or you can sit there and say debug window local, and now here's all the variables you have access to. If you want to, you can sit there and right click and say go to watch window, and now you can have the variable right there. There's 100 ways to look at your data. What you'll see is the way I do things, I almost never use those windows. I use print.
Well, and one last question. Can you see global variables? Like, let's say it's like outside in a different class, and then you step into another class. Could you still see the variables from the previous class? Okay.
Yeah.
At the same time. Awesome.
Yeah, and you have access to the call stack as well. Okay. And the things you can do is pretty amazing. But we'll go through, and you'll see as I code in front of you more and more, you'll see more and more things I'm doing that's just our second nature. But it's nothing tricky here. There is really no manual on this. You just kind of explore and click.
Thank you.
All right, so here's the catch. When we call new, so let's go down here to this one here. So here's car. Car's a class. So car's a class. So a structure can be declared on the stack or be called dynamically. A structure can be either. So here's the structure on the stack or dynamically allocated on the heap, right? A class has to be dynamically off the heap. So here's car. Car right here is a class. And because it's a class, it has to be dynamically allocated off the heap. All right, so here's kind of the secret decoder ring. If you declare something off the heap, right? So let's think about this right here. Think Java for people who aren't comfortable with C# yet. In Java, you sit there and say car, and then you go new car, right? This is on the heap, right? What is this variable?
A pointer.
Pointer.
In Java, it's a
reference.
In Java, I think they'll call it a reference, right?
Yeah, it's a reference.
I'm gonna break your world right now. It's really a pointer. So in Java, you've been using pointers all along. They just think you're too scared to call it a pointer. It's actually a pointer, not a reference. So all along, Dorothy, you've been at Oz. You had the power all along. You didn't have to go see the Wicked Witch of the West. You had the power. When you dynamically allocate something in C# or in Java, you get returned a pointer. Not a reference, a pointer. Right? So what I do is I just put the little word P in front of it just to kick me in the head and say, hey, it's a pointer, Ed. So when I call new, I just put the word P in front to kick me in the head and say it's a pointer. This is on the stack. I don't put P in front of it. All right? So this is a pointer. Now in C# and in Java, they don't want you to use the arrows because that's scary. Because that reminds you that you're using a pointer, so they change it to a dot. So this is really, if you're in C++ land, it's P, Jetta, arrow.
Is there like the concept of the copy constructor and everything like that?
Yeah.
Still in C#?
Mm-hmm.
So it just kind of doesn't have the star there.
Right.
Telling you it's a pointer, but it would still function the same as a pointer if you had like, say, another car and you gave it P Jetta.
Yeah.
It would not copy construct, it would do a pointer. Like, how do you make that distinction? If you have like car P Honda is equal to P Jetta for some reason.
That's a pointer to a pointer. You're just assigning two pointers.
Okay.
So like here, if you had this, if I understand, so P Honda, right?
Yeah.
Okay. Then it's somewhere you went like this. You went P Jetta.
Oh, I meant if you went P Honda is equal to P Jetta. Or yeah, that.
All right. So think about what you did just right here. We just
So that's
took,
pointer.
we just took the pointer. This pointer you points to. Let's call it car A, right? And this is car B. Just keep it clear, right? We just said now Jetta points to A, Honda points to B. Now Jetta points to B.
Oh. Okay. So then if you wanted to actually copy it, you'd have to specifically say new car using, say, P Honda there.
You would have to then do a deep copy.
Okay. So you have to manually do all your deep copies, otherwise it's just pointer exchange.
Right.
All right.
And in that case,
I
would
missed
there,
the stars.
Yes, I do too.
in that case, would there be any kind of memory leak? Because you're
Oh
just
no. Okay, so this is the other thing that completely sucks. Remember, I'm a C++ guy because we have a lot more control. C#, it thinks it's doing you a favor. First of all, true or false? Does Java leak memory?
No.
No,
Yeah.
it does not.
Okay, false. It leaks memory. C#, does it leak memory? True or false?
Yeah.
False.
They both leak memory. They just leak it in a most hideous, heinous way. They give you the illusion that you think it's not leaking memory, but they leak memory. Most of the time, the garbage collection can rectify it, but a lot of times it does. It deals with lost cases by actually aborting your process from the operating system. So, managed language leaks memory. Shock. All right. Anyway. All right. So in this case here, right? So we went into this tangent here. All right. So in this case here, Honda, at this one right here, on this line right here, Honda has a reference count of 1. Of 1, right? Reference count. Right? Now, I'm sorry. And then this has a reference count as 1. And if we, as soon as we do this assignment over, let me change this around. Let's flip it around. Okay. So here, so now we're basically saying Honda now equals Jetta, right? Who's referring to this original car here? Who's referring to car B? Right? This reference count is 1.
I mean, now
So
no
that's
one
the memory
is.
leak. Excuse me.
No, right. So now what it is its reference count now is car B.
Has a reference count of 0.
Is 0, right? So now it's basically marked for deletion. It's not deleted. It's marked for deletion. And the compiler and the executable may delete it at the worst possible time you want. You have no control when it deletes it. It may delete it when the program ends. It may delete it 3 lines into it. It may delete it in a function that you need to go really fast. It goes, nope, I'm going to go delete it right now. It will delete it at the worst possible time. So garbage collection here is it's reference counting. When there's no reference counting, it's marked for deletion. When it's marked for delete at some nebulous time, at the most inconvenient time humanly possible, it will delete it. Right?
So then instead of letting it delete it, can I just delete it myself?
Nope. Welcome to managed languages. They really suck. So here's the catch. And this is the reason why I'm only talking about this is normally I don't talk about this until later. Our goal is we want our code to run really fast, right? So we're never going to give our resources back to the system. Everything we have, every new we create, generally speaking, will always be alive and will have an active reference on it. if there's always one reference to it, it will never go deleted. It will never be deleted. If it's never be deleted, it can't slow our system down by deleting it. So our whole goal is to recycle our allocations. So we create a car, we use it. When we're done using it, we give it back to the car dealership. The car dealership holds it. You need a new car? We take the car dealership reserve car that we have sitting in the lot, we polish it off, change the spray paint color, and give you that car now. You use it again, you're done with it, you give it back. The rental place takes it back, it washes it. Oh, I want a blue car? We paint it blue and we give it back to you. We never create a new car unless we need 2, 3, 4 new cars live at a time. So what we're going to be going after is a memory pooling aspect in this class. And this is going to make the code run really fast.
So you can't have just car variable name on the stack, right? Because it's a
You got
class.
to transfer the ownership.
So it has to be associated with something on the heap.
Yeah, we'll let's before we go into the weeds there, let's
Okay.
continue here. Yeah. All right. So here it is. Car is a reference, which is really a pointer. So I put a pointer here. So there's car, and we can go dot x dot position in D. We can get access to everything. Boom. Right. Position is a stack variable, so we can sit there and boom, move it to an object. So we boxed it. So now what happens is it created dynamic memory. Now it points to a location called position. We want to bring it back to the stack. We unbox it so we can cast it back to a value. There's unboxing. So we have boxing, unboxing. So this is going to take its stack value, put it up onto the heap. This is going to take a heap value and bring it back to the stack. So let's think about what's happening here. When we do this assignment here, it's going to create it's the same as doing this underneath the hood. It's the same as doing new position, right? We'll get this. And then copying ptemp.x equals position dot x, ptemp.y equals position dot y. That's what this code is doing. And then this is called, instead of ptemp, it's called pObject.
Yeah.
So this is creating the space, copy the data into that space. Then unboxing it is going to take that dynamic, copy the XY back to the stack, and then free that up. Or I'm sorry, mark it for free. Mark it for delete.
If we did a pause 3 and did the same unboxing, those are 2 separate instances of position, right?
So position
Like if you did another P object there, how does it know that it shouldn't have deleted it already? Or can you only unbox once?
It's already defined in the scope. Oh, I'm sorry. Let me do a different number. D8 there. let's see here. This is not. Oh, this reference isn't dead yet.
Oh,
It isn't dead yet.
and if it was dead, it would either point to something else or
Right. Yeah.
be out of scope.
Yeah, that's not. It's not. It still has a reference count. So this has a reference count of 1, right? All this does is says copy the contents to here. It didn't change the reference count. Now, if we did this, now it doesn't have a reference count, right? Boom.
But wouldn't it just try and
No, because my reference count
doesn't
is
try and
0.
unbox null?
Right.
Oh, it does throw an exception there.
Yeah, it's going to throw an exception, which is correct. It should. So this case here, you can look at it in one of two ways. You can look at this as it's trying to unbox a null, or this object now has a reference of 0. Now you're trying to unbox a reference of 0. Generally speaking, I never use boxing unboxing, but I just wanted to show you this because that was a thing. All right, let me go through the last couple things and then we can start coding something real. All right. Oops. Okay, so here's reference car up here, golf. We access the golf, then we can print it. So let's do that. All right, so there's golf. Boom. And we load it up, and then I have a print me, which prints the stuff on the screen. You can see it on the screen. All right, add 100. So I'm going to go in there. So I'm going to basically pass the pointer into add 100, and now I'm going to boom, 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 add 100 to it, and then print it out. And now you can see it has 166, 177, and 155. So 100 was added to it. Now I'm going to have this other mechanism called out. Why is my screen shared? Save. There you go. All right. All right. So here. In this case here, I'm using this keyword out. Have you guys seen this word out before?
Yes.
It's basically, it's an external. So this is going to return an object called position 3. So in this case right here, I create the space for position 3 on the stack. And now I go into the code here, and I go into it. Now it's going to update these two variables. Oops. There you go. These two variables here. And it's going to update it, and it's going to return it back out to position that it came in as. And now I can print the position 3. And it's going to be the 211. So out is basically returning by argument. So out is returning by argument. Then
Will we be using this often?
Excuse me?
Will we be using the out often? Okay.
Yeah, so let's say you have a method and you want to return 5 different items. You can only return one thing at a time, right? How do you return the other 4?
You can only return one thing at a time. You can't return all 5 items.
Return.
Yeah.
So if you want to return it, you would use out.
Okay, so only with out can we return all 5 of the items at the same
Right.
time.
So think about this, right? So on any method, right? On any method, you can do this. You can say, I can return an int, right? And you have, a class dot method. right? And int x, right? So in this case here, let's say you have this is inside a class. Right? Here you can return int, right? That's easy. But what if you want to return float and a bool, right? What if you want to return those? In C++, you would just go, hey, return those, right?
Mm.
In C++, that's what you would do. Here you just do out.
Are those two, like, those symbols, are they actually equivalent or are they just,
They're equivalent, yeah.
they're, okay.
Yeah.
Oh, so all you're doing is you're just passing by reference. That's it. Okay.
It's returning by reference. Returning by reference. Out is return.
Okay.
I think there's
I
an
get
in
it.
as well to pass by reference.
Pass by reference, you don't use the word out.
I think that's in, I think.
You don't need it.
So you're returning something by reference. Is that what you're saying, right? That's what this does.
By reference, right? So here,
okay, yeah.
Here it is in C# land, and then here it is in C++ land. So.
And does this do the Java thing where is it always pass by value until so like basically it's an input parameter unless you specify the out. So it's not like Java where objects are passed by reference and primitives are passed by value?
Nope, that's how it works. Yeah.
Okay.
It's passed by reference always. So okay, this is first of all, this is out. This is out, right?
Yeah.
Does everybody kind of follow that? Out is just basically returning. If you wanted to void method and you pass in, cat. Oops. You fool. Stop auto completing. Cat. There you go. All right. So this right here, I'm passing in a pointer, cat.
Okay.
Right. And in C++ land, that's this. Whatever, for whatever reason, it really is hell bent on finishing that for me.
I think you can just Control Z to undo whatever it did.
So these two are equivalent.
Just press escape when it does that.
Thanks. These two are equivalent. So you're always passing it in as a pointer.
Oh, so even like bool and everything else is a pointer.
Everything, bool is a value.
So.
Oh, okay. Primitives are values then.
Structures and primitives are value. Classes are pointers.
So if you want to pass something by reference, you have to specify out when you're calling to a function.
But when you want to return a value by reference, return.
So reference is the pointer, is what you're saying. But you have to specify out, is what you're saying. So you can't just say pos 3.
Return, right. So then there's.
So it would receive an error if you don't put out, is what I'm saying.
Yeah, you have to do out if you want to.
Okay.
Otherwise,
I think what's confusing there is like, so if you were to pass in just position without the out into a different get position, you can't actually modify it.
You can modify it, but it won't update it. It won't return back.
Even if you were passing in a class, because I thought that was a pointer.
If you pass in a structure, it copies by value.
Yeah.
So you're modifying the copy, but it has no lifetime once you come back out of that function.
Oh, so it doesn't give you an error if it's like if that's the parameters requirement.
Right. Yeah. It's an argument.
So we don't even know. So,
It's
okay.
out only return stuff out.
Okay, I get it.
Oh, you're gonna. Given how much complexity that was giving you guys, you're gonna hate this one. Ready? What if you want to change a reference that's passed into an argument? So here's car, right? Car is dynamically allocated Bing, right? Then Presto is going to take a reference to this, and now I can change it. So let's go to that. Here we go. All right, so this one's car, boom, and we print it out, and you can see right here. Here's the printout, 88, 77, 99, right? Now I go into this, and now I call new car, and I change the pointer itself. And now I get a whole clean new. And see, it's 223311.
How is this different to out?
It's this changes the pointer.
Okay.
So this
So you
this,
change.
this
So you
is the
point to
equivalent-
something else
This
versus
is the equivalent
changing.
in C++.
Okay.
This is the equivalent in C++ is
Reference to a pointer, right?
right.
Oh, it's just the address. You're changing the address, right?
It's a reference to a pointer.
Yeah.
Yeah, so what I meant above was if you have void method car X and inside method you modify X. So you say like say X dot position equals 000 or something.
And this one here.
No, so using car, since that's a class, not a structure.
Mhm.
So car dot some function takes car as an argument.
Mhm.
And you say modify something on that argument inside func.
Right. That's a,
When you come back out, is car changed or
it's a pointer. It's a pointer to it, so the value would change.
okay, so it is
Yeah.
so
We-
classes are passed by reference. And so you could effectively not use the out if you didn't need.
If you
you
didn't,
didn't.
need to, right? It's like you
Whereas you need it on the structure because it's
on
passed by
structure
value.
you need it. So outs you need on structure or values.
Got it.
But if you're so like here I have add 100, right?
Mhm.
So I create a car golf. I go into add 100, add 100, adds 100 to every value inside of it.
Okay, and then it comes
Then-
back out and it's had 100 added to it because it's modified the actual memory. Got it.
So
That's what I
out-
was confused about.
Yeah, out is for values, so intrinsics and structures. Everything else is like standard Java. And then if you want to change the pointer itself, the reference itself, you use the keyword ref. That's that. So, okay, so this really, does it make sense? Is anybody getting hung up on this?
No, that makes
Yeah,
sense
and the
now.
first, yeah, you're just passing by value basically, but reference, and then the other one's just the pointer, changing the
Right.
pointer itself.
And
Yeah,
one of the things here is you're going to get this code so you can walk through it 100 more times. But basically, it's what I try to do here is do every combination that you can do so you can kind of see it. So here's just a structure on the stack. Here's a structure dynamically. Here's a class dynamically. Here's boxing a structure to a dynamic object, then unboxing it. Here is a dynamic class. Then we're going to add 100 to all internal variables. This is, in this case here, I'm going to create a class dynamically. And then I'm going to return by argument a stack variable with using out. Here I'm going to create a dynamic allocation. Then inside of this function, I'm going to create another dynamic allocation and reassociate it. So this car points to car A. Then inside of here, I'm going to say, nope, Tiguan points to car B.
Can you still modify it after you?
Mhm.
Okay, so it's just an
I'm just
object,
changing the
and you
parameter.
can
Yeah.
you can modify it before or after, and then even if you
Yeah. So this one
When
here.
okay.
When you re-reference your P Taiwan,
Mhm.
Does that remove the original new, or is that
Yes.
still in memory? Okay.
No, it reduces the reference count by 1.
Okay.
In memory until garbage collection decides otherwise.
Yeah, but but if somewhere else, if I had this, I had car P, rental, right? And I have it equal to P Tiguan, right? So then this case here, reference count is 1, right? Now reference count is 2, because there's 2 guys pointing to it, right? So think of this car A. At first, there's 1. Now I associate rental to it. So now car A reference count is 2, right? Then here I remove the thing. So now A is down to reference count 1. And now B is reference count 1. Oops. So, so here, just to show you there's more reference counting here. A is created, this is car A, count is 1. I associate to another pointer, now is 2. Inside of here, I pass in a reference count of 2, right? It goes in as 2, then it goes boom. And now I reassign it. So now it's P Tiguan is now pointing to reference count B, which is reference count 1, and now I removed 1 from A. So A gets decremented by 1. Goes down to 1. So now when I come through this thing on the other side, at this line right here, A is reference count 1, and B is now reference count run.
Just to clarify, that's because P Tiguan is now pointing to B and P rental is still pointing to A.
Exactly.
Is that right?
Yeah, P rental still points to A, so it still has to have an active reference count. But because in Presto we removed it, it goes from 2 to 1. And then we created a new object that's object B. All right, so yeah, we'll take a look at this stuff. All right, so now let's talk about where we're going in the first assignment, homework assignment. Is this making sense? Trust me, what I try to do here is put everything together very quickly, right? All right, let's see. I thought we were going to have like 2 hours to code. And today I thought, oh, we'll have 2 hours to code. Guess not. All right, so let's go with this. All right, so here's what we're going to do is I want to create a memory system. And I'm going to give you a unit test this week, and you can start working on this. But here's kind of the concept of it. We're going to have a memory system, a manager, right? Then hanging off this manager is a linked list of nodes. So we got a linked list of nodes here. And the idea is that this manager is going to hold all these nodes as a repository. And what we're going to do is we're going to have here, we're going to have a reserve. Sorry, this is so ghetto, right? So we're going to have all these nodes here, and this is the reserve. And then we're going to have, hanging off of this, an active, right? And the idea is like, hey, manager, I need a node. Like, you need a node? Cool, I got reserves. I'm going to give you one of these. So I need a reserve. Okay, cool. I need one. Okay, great. I happen to have one on reserve, so here you go. And I'm going to give you that one. I need another one. Hey, manager, I need another one. Okay, cool. I got one. There you go. I need another one. So you know, you get the drill. I'm done with B. Here it is. You take B back. All right, thank you. I'm done with A. You take A back. Okay, cool. I'll push it to the front of the list. I need one allocation. Okay, cool. Here's your A again. I need another one. Okay, here's B. I need another one. Okay, here's this one. I need another one. Oh shit, there's no reserve. First, refill the reserve. Now, I need one. Now I pluck it off. I'm done with A. You can have A back. And all we're just doing is going thrashing back and forth between reserve and active. Does that make sense? I just totally like how it looks like a
Professor, this allocating and deallocating is always happening at the beginning of the list, right?
No, this is not. There's no allocation or deallocating. We're reusing and reusing. All right,
So we just need to add to the beginning and remove at the beginning.
Right. A beginning, you got to be more specific. Beginning of the list or beginning
of the list, of the linked list.
Okay, so yeah, so here's the manager, right? So the manager starts off, and we have a reserve and an active. So active and reserve, right? So when the first thing starts off, the active and reserve are empty. Cool. So what's the first thing we're gonna do? We're like going, you'll go like this. Hey, I need manager dot add, you know, dot some parameters, and it's gonna return a node, right? And it's gonna say, wait a minute, I have nothing in my reserve. So what we do at first here is we go, okay, when we first create our manager, we populate it with nodes. We say, you know what? We're going to populate with 2 nodes. B, okay? So when we first create our manager, there's 0 active and there's 2 on reserve. When we call add, I'm like, I need one. Cool, I got a reserve. I'll take one from reserve. And I move it to an active. Right? Then I turn around and call this again. Man, hold on a second. All right, so here's our so like I call this one, right? And I'm like, okay, cool. So my initial point is all right, so here I am initially. I call this line of code, add one. Oh, I'm like, oh, cool. I got one in reserve. I take one and move it here. Right? Then I turn around and do it again. Then I'm like, okay, cool. I can do that. I'm going to take this one. And what I'm going to do is I'm going to always jam it to the front of the list. Here, right? So when I do this again, I move the second one there. Now I do it a third time, and now it goes, oh man, there's no reserves left. Refill it. So then I'm going to refill it. I'm like, okay, I'm going to refill always with 2. So I'm going to go C, D. Now I refilled it. Now I need one for this last line I just did. So now I'm going to take C off, move it to that list, right? Now when I'm, let's say, down here, I go, okay,
I asked you a quick question. Are you treating these as stacks?
no, this is just a memory. It's a class memory pool. So remember
Okay.
one of the things I said was what we're going to try to do with our memory manager is never give you an allocation back. Never delete something, right? Never let the reference go to 0. So this object here, it's always going to be on the manager. And you remember these are going to be little, little, these are diamonds. These are always owned.
So if active gave C back, and then it gave B back, where would B end up? Would B be in the front of Res's list?
So let me do that right now. So so P node. Let's just do PB. Alright, so now let's say I'm doing this one, remove PB. Then what I'm going to do is I'm going to take PB off of the active list and put it back onto the reserve list.
Okay. So if you did C next.
So what about C?
Would it be BCD or would it be CBD?
These are two
Or does
separate
that not
lists.
matter?
These are two separate lists.
Yes, I know, but if C was then removed,
Okay, but so if let's do C removed. So,
Yeah, I don't think it matters that much.
what do you
that's
mean?
what I'm trying to figure out. If that's like
I'm
part
trying
of
to
the
understand your
assignment, or is it
question.
just
What's the question? So
is
now if I remove
the
C, right? If I remove C, C will land right back in the front of the list.
okay? So reserve is acting like a stack in this example.
Well, it's not a stack. It's pushed to the front.
That's a double linked list, yeah?
Yeah, it's a
So you
double
can do
list.
that in
Right.
just one move.
Right.
Yeah, pushing to the front is much easier because you have the access to the
faster.
head pointer.
Right, exactly. It's faster. So we're going to push and pop from the front, right? of the
First in,
list.
first out. That's a stack.
Okay, you got to remember, you got to be much more specific. Stack also
Oh,
means
no,
continuous
queue.
memory.
Yes.
Right? Yeah, it's a queue, all right?
It's a queue. Sorry.
Yeah.
No,
so,
wait. If D would be picked, that'd be the queue.
Okay, no. So now the catch there is like, okay, now I want to add one, right? So let's say I want to add one.
It's first in, last out.
You go right back here, right? I need another one. Then I would grab B, right? I need another one. I grab D. I'm done with C. C gets added back. Okay. I'm done with A. A goes to the front of this. So let me get my house ready.
That answers my question.
Yeah. All right. Now, here's the reason why this is interesting is that the manager always owns the pointer. These are references. I mean, these are PO, right? Pointer own. But basically, we're going to go, we're going to check the book out from the library, read it, and return it back to the library. The library doesn't care what the order of the books are. You just give me a book, and I will take this book, wash it off, and then fill it up with data, and then hand it back to you. So you keep doing this, and then when you're out of data, right? So let's say, and then you're going to see you need another one. Here's A. You need another one. Here's C. Oops. I don't know what I just did. And then I needed C. Now, all of a sudden, I need another one. I'm like, crap, I'm out. So now I create E. And then I create F. So I refill the reserve first. Then I need another one. I grab E. Put it back. If I delete one, let's say I delete A, it goes back to the front.
So when manager is deleted, how does the reference counts for all of these go away? Like, how does it know that they're all kind of chained together in that linked list?
No, they're never. When you create an object, it always lives on the manager. The manager will always have an active pointer to it. It will either be on the active list or on the reserve list.
Okay.
This is a sticky list. So initially the list is empty, right? So initially the list is empty.
Well, I guess since there's no concept of like delete, when you delete your list and it deletes, normally you'd go from like p head and you'd go all the way through your list, delete each individual node in the list, and then you're done. How does it know that all those things are linked together, or is double linked list like an actual I guess built-in
No,
list
no.
type, or we're building our own,
We're building
right?
our own, yeah. No, so what happens is, at some moment in time, there's going to be multiple boxes. Right? So let's say that's our moment in time, right? So every single box has at least one active reference count to manager.
Yeah.
Okay. So what you're doing is you're basically going to the manager and go, hey, can I get one? It just removes it from reserve to active. Oh, I'm done with one. Remove it from active, put it back on reserve. That's all this manager is doing. Now, how you use it is when it's recycling it. So when you're done using it, it goes back to the rental store, and it can get erased. And the data stays, the space stays there. So dynamic allocation stays there, but it gets erased. And when you call add, it can get repopulated with new data. So we're truly recycling it. The ownership, the black diamond, is associated to the manager. And the idea is that this becomes a sticky list. So let's say I do this. At first, my manager is empty. And then I'm like going, okay, add. I add like 4 of them, right? And then I now a little bit later in the game, I need another 10. Then a little later in the game, I only need 3, so I delete 11 of them. And then a little bit later, I add 12, right? At the end of my project, right before I close the game, I go, hey, what's my stats? They go, hey, your manager at one point had 220 allocations. Had 220 nodes, right? Like, thanks. The next time I run my game, I pre-allocate 220 in my reserve. Do you see that? Then it's
Yeah, no, that's all the same as the other class where we did the manager system. I just meant when you actually delete manager, how does it handle the, because like some of those,
so there, yeah. Okay, so when you actually call the delete on manager, right?
or when the system decides it has a reference count of 0. Yeah.
Right. So we have the manager, we have a manager create and a manager destroy.
Mm-hmm.
On manager destroy, you unbind each of those nodes. You basically zero out the nulls. Yeah, the reference.
Okay, so you set it all to null, and for any that aren't currently in use, that means their reference count's now 0.
Right. Because
okay.
And then that marks it for delete, and then the system cleans up right when it closes.
Okay, so you kind of just have to force the reference count to 0 instead of actually calling delete.
Right.
Got it.
Or if you don't do it,
it'll still go away eventually.
It'll still go away. It'll just do like a forcible kill.
Okay.
But the reason why this is a performance win is that we never give that resource back to the hardware. It stays alive and it can be recycled. So at any time, we're only paying for the number of active objects we're using, at a moment's, time. We're not, you might only use peak 20 allocations, right? But you might allocate 5, delete 3, allocate 2, delete 7, allocate 5, delete 4. You might do this ratcheting back and forth 100 times, right? A million times. That's a lot of news and deletes. Those are all slow. That's a lot of garbage collection. That's slow. That's going to happen in the wrong spot. Here we're just saying, just keep recycling. Oh, wait a minute, we got a new max. Okay, this is the only time you call new, when it's a new max, and that's going to slow down the throttling and the memory allocations, and that's going to make the system much faster. Right. So now this is the concept: is we're going to have this manager that has active and reserve. Now, how do we deal with this? This is where we're going to create a base class called D-Link. And this is going to have, next and previous. Right? And then below it will be our whatever we're going to manage. This might be our node. And our node's going to have, whatever kind of data in here, X, all kind of fields. So this is going to be our D-link. Then coming off of this is our D-link manager. And this is going to point to this. This is the head. So what we're going to have is a D-link manager points to a link list of nodes. So we go a little further here. I really wish I had a marker that would work. Right, so we would have a D-link here with next and previous. And then we would have our node, some dummy node here that has like values X and Y. But then this will be managed by a D-link manager. Then the manager will, all this manages is one link list. So we will have two of these. We'd have one that is reserved and one is active. And now we would have this. So hoping we can code this. So this is kind of, where we're going with this. Obviously it's going to take a little more effort to kind of show you guys how to get there. Basically what we have as a manager, it has a active list and reserve list. Just pretend, for instance, just the reserve list. This is the reserve list. We have a D-link manager. We add to the front, we add to the end, remove first, and then this will be pointing to a D-link, and then everything we deal with is down here. So what we have here is the D-link is our mixed in variable, and this is our data. And so this is going to allow us to basically have manage multiple link lists of this, and we are getting towards this diagram, which is manager, active, reserve. So conceptually, this is what we're going to have. So that's what it's going to look like conceptually. And then implementation wise, we have the link manager points to the link node, and this So this is kind of what we have. And this is going to be the actual implementation of that. And what we can do here is it's a double linked list, so therefore the deletion is order 1. We're going to add to the front of this D-link, push to the front of this D-link, but when we delete, we might delete any one of the actives, so that's why we want to have a double link list. And then when we remove one of these from this double link list, it gets moved on to the reserve. And then this man here will be generic, and we will have underneath here node manager. So essentially, this is a reusable class. Gotta like my stupid drawing. And then these are, we write it once, we use it. The manager. And then the D-link. So essentially all we need to do is to create a manager is just derive from D-link the node, just drive this from a D-link, and then create our node manager from a D-link, and then boom, we got a memory manager that does recycling nodes. So this is where we're going. So I'm going to get you a unit test to kind of start nudging you that way, and then next week in class I'll have a marker board and do this properly and kind of show you where we're going with it. But this whole idea is we're trying to use this memory manager, and we're just moving stuff back and forth, back and forth, back and forth, back and forth. And the idea is that we would get, that's the actual implementation. This is conceptually what we're doing. And we're using mixins for this. So why are we doing this? What's the whole purpose of having these managers? There's a lot of resources that we're going to be using while the game is running, right? All the graphical elements on the screen, all the sprites, are using managers. The sub-region of the textures are using managers. The textures themselves are using managers. The collision boxes are using managers. The audio systems using managers. So we're using these managers all over the place because we have these multiple laundry lists, right? So the question there is why are we doing managers and not just using containers, right? We can do a dynamic array or a vector and just use containers. The problem is containers, you can't control the deletion, the allocation, and the growth of those containers. And so every time the system can control a new and delete for you, it's going to do it at the wrong time period, and it actually causes the system to go slower. So this way here, every single new and delete we get control, and we can monitor how many there are and how many are active. And any node we look at, we can point to and know its ownership and its lifetime.
So for the assignment, can we start on it whenever, or are you going to post something like a template to start with?
I'm going to, what I'm doing right now, and I'm going to show you this is the unit test so far. So hopefully it runs. I'm trying to shake out the unit test so this way I can give you something you can just run and start coding. Yeah. Okay, so this is the unit test.
I take it you'll give us like a design doc as to what
Yes,
methods
you'll
you
get
want
it.
expect to have.
Yeah, you'll get. I just want to show you this because it may look a little weird. All right, so you're going to be given code, and you kind of have to fill in the blank. And you're going to get over here on this screen right here. You'll get, here's your unit tests. This test passed, this test passed. It will tell you how many were ignored, how many passed, how many failed. If you don't want to do a test, let's say at first, you're like, oh my God, nothing works, right? I got so much code to write, and I'm just getting compile errors and everything else. All you do is go here to the configuration and say, oh, turn it off, right? False. In false. And so you turn all your tests off at first, and you run it, and it goes, oh, they all got 0 pass, they all were failed. I mean, they all were ignored, right? Then what you do is, okay, I want to start working on the first test. So you turn around and do the first test. Just turn it true. And then once, now that test runs, and it says this test has been passed, and this test has been ignored, right? So you can kind of see the count. If you wind up screwing up something, so let's say here, so this is 3. So this thing just failed. You can just double click on the error to fail. Just double click on it, and boom, that's the line that failed. You can put a breakpoint on there and check your code. Run it again and go right to it. Boom. It tells you now you have stack. You can go look at your variables and kind of see what's going on. So that's one thing. The other thing is, let me close this. Here it goes. So this is what will happen the first time you run it with an error. You'll get this exception, right? Just open up the exception and clear it. And now we can turn around and do this again. There you go. So the first time you run it, it'll kind of throw an exception, and that's it. And how it works is my unit test here, I'm using reflection, I'm throwing exceptions, I'm handling exceptions, and it's going through a whole rat's nest. If you care to look at it, you can go into unit test space, and here's all the code that I'm doing the unit test with. So you can kind of see what I'm doing. I'm not hiding anything, but it throws in exceptions, and the exception gets propagated through the stack. This way I can track what line and file you're on. So when you get it, you get an exception, just clear it, and then now at that point you'll get these registration. You just double click and it tells you where your error is. So when we do this unit test here, you have the flags you can turn on and off to only test one function, to test all the functions, whatever. Once you get something working, leave it on. And then when you run it, it'll tell you which error it is. So you can double click and kind of follow your mistake. And it'll give you a scorecard. So I wrote this all from scratch a couple weeks ago. So you'll get this, and you'll get a PDF that describes kind of how it works. Like this. And, you can totally start working on this now. Nothing's stopping you. You can start to prototype and experiment. This is going to take me like at least another day to kind of code this up and get this running. Questions? And the sprint for this week is literally just make sure your environment working. You can record that all I'm going to have you do is record 30 seconds of the demo. You know, so here is just run it, Space Invaders, and record. I'm going to see you compile it and run it, and make sure it runs on your machine. So this way I know that your environment is going.
Is that Saturday or is it the next Saturday? Like
It's,
the usual
oh yeah,
stuff?
everything is due on Saturday, Saturday night. Not this Saturday night, the following Saturday night. This way you have another time in class to ask questions in office hours. So I'll explain this.
Where do we post the videos?
It'll be right in the doc.
Okay.
Yeah, the doc will have the doc will have here your name. Did you cheat? Yes or no? Change this. We'll go over this next week. And you just cut and paste your YouTube link right here.
Thanks.
Yeah, you'll see the drill. It's pretty much the same drill I use in my optimized class.
So both this and the assignment, the double linked list assignment, are due next Saturday. Both of them.
Next Saturday, right? Yeah.
Okay, thanks.
Yeah, and all the Space Invaders one is just, does it work? You know, it's so, you know, just to make sure you're. The one thing I want to emphasize strongly: once you get your Space Invaders running and everything working, do not upgrade. I know it's tempting. There's little buttons like, oh, Microsoft just released a new thing. Don't click it. It's a sucker's move. Don't do it. Just leave everything as is. Once you get your stuff working, leave it alone for the quarter, then update during break, right?
I assume Windows 11 should be avoided at all costs.
I think you should. Windows 11, I've already kind of seen enough of stuff that the people are prototyping it right now. There's some big problems right now with it.
Just keeps trying to sneak the upgrade in. That's all.
It's totally trying to sneak it in, yeah. All right, so I apologize I don't have that marker board. That's what's been causing some grief here. You guys will get this. This first week is a little rough just because it's a new environment, new everything, but we're going to start moving after that. Questions?
I have a quick one. Is there a suggested software to record our screen that is like better than others?
Yeah, we can. Screencast-O-Matic works well. There's can start a thread on Piazza. Just ask a question, and several people have used several different tools.
OBS is good.
Yeah, OBS is very good. So just post on Piazza, and we can kind of start a thread on which one it is. I've used a lot of times Screencast-O-Matic or OBS. And that's the other thing is I want to make sure that you can talk clearly and I can hear you on this. I get videos where the person, I have my speakers at a full maximum and I still can't hear what's going on. So so the videos is also, this first week, it says make sure your audio levels and you can record well. The videos that are recording are private. They're sent to me. They're not for anybody else. And you know, they have really not much value other than academic. So don't worry about it. We all sound silly. Anything else? All right, I'm gonna let you guys go. Thanks so much. I'm gonna convert this and upload this, and then upload all the lecture notes, and then I owe you as soon as I get the homework, and this way I'll post it up there and tell you that the new homework assignment's out. I'm going to close this out, and I'm going to open up office hours. So just follow the new link for office hours.
Thank you.
Thank you.
Thank you.
Thank you, Prof.
Thank you.
Yeah, thank
Thank
you.
you.